Hey everyone, welcome to the Stateless Implementers Call number 33. I will share the agenda in the chat. As a brief summary, we have the usual team updates. Then we have a presentation from Julian about the protocol design view on statelessness if research post. And then we have some EIP discussions about the overlay tree EIP and this tree conversion EIP. So let's start with the team updates. I can start first. So I've been working on adding some extra tree conversion execution spec tests, and I've been sharing them with some people, and yeah, they have been running them, and I think they will give their updates, but things look pretty well. I also wrote some other document that I shared with Spencer regarding some internal things that we have to do in the testing framework. This is like mostly technical debt created while creating all these tests. So we have to work on this, and we'll be mostly transparent from everyone else, hopefully. And I also wrote some documents regarding EIP 4762 worst case scenario for block sizes. So this is in the context of helping a bit Tony from the ARC team that is working on a refresh take on worst case block sizes. And worst case for Burkle is a bit different from the usual way you think about it currently in mainnet. So yeah, I will share it in the chat just in case somebody else wants to dig more on that. But I think in the future we will probably discuss this further because it might require some tuning in the constants of 4762 or not. I mean, it depends on what we decide, but I think it's interesting that maybe more people read this document. And yeah, we've also been working on some new pages in the Stateless book that hopefully we will finish reviewing internally soon, and they will get published, but I will mention that in probably future SIG calls. That's all from me.
Yeah, I've been working on like 2 weeks ago, I think I was working on implementing binary trees so that when we want to make some measurements we can. I realized I haven't tested it, so yeah, the implementation is there, but it hasn't been tested. And last week I was working on implementing the transition into guest master. Yeah, there's been a lot of back and forth, a lot of redesign that needs to happen only at the code, right, and not at the EIP level. But it would be pretty cool to have guest master being able to go through the transition. So this is going to continue this week. Yeah, hopefully we can get somewhere.
So from my side, I've been mainly working on the integration of statelessness with fossil, kind of trying to identify possible problems or incompatibilities, and also things that have a good symbiosis between them. So far it's looking nice. Identified one particular thing that I think we all agree that requires further discussion, which is how do we actually solve IL flooding attacks within any regime that uses statelessness, so weak or strong. And aside from that, planning to start executing some networking benchmarks, as networking is also highlighted as one of the most critical things on statelessness, since basically we're trading disk or hardware by network. So I will likely be using ETH Shadow to do this, unless someone has a better suggestion, which I would definitely encourage mentioning it, whatever it is. On the post-quantum Berkel side, not much news this week. We're doing some meeting, I think it's on Wednesday, with Matan and some other cryptographers and also Arancha from the cryptography team. We're trying to look for a very particular vector commitment based on lattices with certain properties that Sweet Berkel tree needs. And so whether we will find it or not, it's an unknown, but at least we want to know if it's possible for this thing to exist or not. So that's what we'll be also working toward.
Okay, on Bezos' side, so we mainly worked on the transition. We had to try to fix some issues detected by the test from Ignacio. I have also to modify the code in order to pass some tests because we are not completely agree with Get regarding how we are migrating the code when we are modifying an account. So normally it should be fixed soon. I don't know when, but yeah, it should be fixed soon. And also Luis detected maybe an issue when we are doing some rollback of the Verkel state. So we will have also to investigate that. And yeah, it was mainly the work we did during the last weeks.
On the side, it's same as Pesu. We also worked on integrating transitions with the vocal code base, and we are also passing most of the tests. There are some things that everyone does not agree on, and we'll probably be discussing those today. So apart from those specific tests, all the other tests we are passing. Apart from that, I also started working on rebasing the vocal code base on Pectra, and I'll be done in like a week or two, and after that, I'll start integrating the transition on over the rebase as well.
On Ethereum JS side, we haven't made as much progress as we expected on the transition because we've been focused on our annual release. But the work is going to resume this week for the converting to MPT to Virgil.
Anybody else want to give an update?
I can quickly mention where I'm at on the testing execution spec test side. So with the framework updates, I've basically finished a long overdue rebase. And yeah, I'm going to start working on these technical debt issues that Ignacio outlined at the start of the call. So yeah, thanks Ignacio for listing these up.
Okay, so the next item in the agenda is a presentation from Julian from the RIG team in DF about an ETH research post that I will share the link in the chat. Yeah, Julian, whenever you want.
Thanks. Let me share my screen. Sorry, give me a second. Sorry, I have to rejoin quickly. Sorry.
Yeah, so this ETH research post is highly recommended for people to read it. I find it pretty useful. So yeah, and now Julian will do a presentation to give like a TLDR of it. You are muted. Yeah, let's wait for a minute if Julian can solve these technical issues, and maybe if not, we can go to the next item and give him a bit more time.
Sorry, it didn't allow me to click any buttons, which is kind of annoying. Okay, I think there we are, finally.
Yep.
Okay, so thanks for hosting me. Yeah, I'd like to present the protocol design view on statelessness, which is also an ETH research post, as Ignacio mentioned. This work that analyzes the statelessness design space in its interaction with other parts of the protocol. And we treat the individual roles that validators have, like the testing and block producing, as separate. So to me, statelessness is really about jointly choosing the proof server node architecture and state growth. And the proof server node architecture will be the nodes that the protocol expects to provide state to users. And what this means is that if the community wants extremely large state growth, then the proof server node architecture may not be so robust. Perhaps only a few agents are able to provide the state and thus proofs. On the other hand, if you want extremely robust proof server node architecture, then state growth can't be so big. And that's pretty much where we are today. The testers provide the proofs, that is, they provide the witness, the piece of data that convinces the attester that the state used in the block is part of the canonical state tree. In turn, we have fairly small state growth. The core idea behind statelessness is that attesters should not be the proof server nodes, but who should be it then instead? In my opinion, that's an unexplored area and the central question of the recent post I wrote. And so I try to contribute to that question by answering 3 sub-questions. First, assuming a weak stateless protocol, is it necessary to implement partial statelessness in protocol? Secondly, what's the fundamental difference between weak and strong statelessness? And thirdly, how does state growth constrain the gas limits in a weak stateless protocol? So we'll start with the first question. And the first finding is that in-protocol partial statelessness is not necessary if there is weak statelessness. The idea is that partial statelessness uses a state expiry rule to partition the state into an active and an inactive set. The most known one is that state expiry rule, where the state is moved from the active set to the inactive set if it hasn't been touched in 6 months. And attesters should all adhere to the same state expiry rule. If they were to hold different pieces of state, it may cause forks. However, in the stateless world, attesters wouldn't be holding state, so they don't need to act upon any state expiry rule. But we still may want a state expiry rule for block producers, because they now have to store a lot of state. But the finding here is that block producers do not actually have to adhere to the same state expiry rule. If a block producer wants, they can store a piece of state, and if they don't want to, they don't actually have to store it, and nothing forces them to store it. The only thing is then they can't interact with a piece of state. So the simple example here is if a block producer is interested in account 1, the green node, it must store account 1, and it must have access to 2 and B to create a witness. But it doesn't have to store 3 and 4, for example. And therefore, builders could use their own state expiry rule, and it's not necessary to have one in protocol if the testers are already stateless. So that might be useful for if we're growing a state beyond a state that we expect builders to be able to store. And that being said, obviously, it would still be nice to have a universal state expiry rule because it's better for user experience. But that universal state expiry rule could be stored off-chain. So you may be asking, why would block producers do so? Why would they prune some of their state tree? I would see 2 main reasons. The first one is some state is not economically meaningful, yet storing it does impose costs. So some state is not interactive with much, or its interactions are not very valuable. In today's MEV boost market, we see builders leaving out transactions because their value is very small compared to the value of the large MEV sources. So this happens in blocks where there's a huge arbitrage opportunity, then some small transactions may be left out, just because the builder can't be bothered to think about it, basically. And this happens even when the builder is not explicitly trying to censor these transactions. It's not about the transactions, it's about the size that they take up in the block. And the second reason would be state growth is too large, and so that builders would not store it and they have to remove some of it. That point may seem surprising. Builders are sophisticated and surely have enough hardware to keep up with state growth. And while that's true currently, I approach the problem from the other side. There could be a state growth at which builders can't keep up with the increasing storage requirements. That is, the protocol could set state growth such that it grows so fast builders won't keep up with it. And we may want to be able to live in that world. And it turns out that if we would want to be in that world, we do not need in-protocol state expiry to facilitate this. And then the second question is about the difference between weak and strong statelessness. In weak statelessness, the protocol expects the ability to store the state, and in strong statelessness, the protocol does not expect the ability to store the state. However, from the previous slide, we know that builders could, in principle, use a state expiry rule at their own will. And so that means that if the protocol expects the ability to store states, it doesn't actually mean that it also has to happen that way. To me, the difference is really in the definition of honest block producer behavior. So, and in weak statelessness, the protocol expects an honest block producer to store the state, while in strong statelessness, it doesn't expect this from honest block producer. However, we can't rely on honest block producers in principle, because there are only two major ones, and they are rational profit-seeking actors. So we have to find some other parties to store the states in either weak or strong statelessness. The honest block producer definition is still important because it helps to design other parts of the protocol. For example, Fossil. Fossil pushes builders to behave more like honest builders. If we say block producers do not have to store the states, then Fossil transactions should come with a witness. If we do say that block producers should store the states, then perhaps this isn't necessary. Finally, we need to consider who holds the state after testers are stateless. Users clearly still need access to the state to create their transactions and potentially to create a witness. In principle, only one non-censoring party is needed, but it should be really clear who this person is. And once we know who these people will be, who the state providers will be, we can reason about how much state growth to allow. And state growth should be set such that users can reliably get up-to-date witnesses from these state providers. To me, it seems intuitive that perhaps dApps and users or wallets on behalf of users seem like natural candidates to store the states. They're more censorship resistant than builders because there are only two major builders. They're naturally incentivized to store the state, and they are less likely to have state that's not economically meaningful to them, which remember the builders would have. And they care a lot more about robust state storage than a builder would. So perhaps an application would want state to be stored in a few redundant ways, whereas a builder might not care so much about that. However, there are also clearly problems, as this puts a heavy burden on applications and users. So that's something we need to think more about. So I guess the main point here is that I'd be very interested in who should hold it, and I think that we should think more about that. Yeah, so that's it. In summary, builders could use their own state expiry rule. So no in-protocol state expiry rule is necessary if testers are stateless. And we should clearly define honest builder behavior in a stateless world, which to me is the main difference between weak and strong statelessness. And we have to think about who holds the state after testers are stateless, because we can't just rely on some honest block producers to keep it. So yeah, thanks for your attention. I'd be happy to take questions here or offline on Telegram. Here you can see my handle.
Great. Thanks for your research. It has been super useful, even for us to get a fresh take on definitions and all these discussions about in protocol and out of protocol rules, and how this connects with the state expiry and Fossil. I know if anyone has questions for Julian.
Actually, I do. Have you explored the last slide, the one who should hold the state? Have you contacted anybody from dApps or wallets to see. Like I think we talked about it before. We said wallets are probably unlikely to hold the state for you. Do you have any contacts with apps or with dApps, sorry, that would be interested in hosting the state, or at least signal that they would be interested in hosting some of the state?
Yeah, that's a great question. You guys probably have way more experience with that. So in principle, no, I haven't contacted applications about that, and I probably should. Yeah, I would say I'm not convinced that applications are the right person. It would be like my first guess, I guess. I would say my conviction is more that builders aren't the right people for the network to rely on to store state. But yeah, I should probably contact some applications.
Yeah, I think that would be, I mean, maybe not just you, but it would be a nice follow-up to figure that out. Because yeah, I agree, maybe devs should not be the person, like the people doing this. At the same time, like you said, builders should not be relied on. And if wallets are, they have no incentives to keep the data, I guess it's gonna fall on dApps to do it.
Yes, Milos?
Any particular reason why Portal wouldn't be considered a solution for this? Since Portal, we are already planning on keep having this data anyway. Or am I missing something from the design, as I didn't look into details?
Right. So we would need to have the state at the head of the chain, and as I heard, Portal wouldn't be providing states at the head of the chain reliably. So that's basically why I didn't include Portal here. Yeah, I'd be happy to hear otherwise.
Yeah, it's not meant as a diss to Portal. It's just that we contacted Piper, and he said wait and see. So that's why we haven't considered Portal yet.
Sophia?
Yeah, thank you, Julian. I'm also happy to see someone thinking about who's going to hold the state in a stateless world, because I've been wondering that for a while, and I don't think anyone is thinking about it so far. Also, I do expect the state to be much larger than it is now, as we're thinking about significantly raising the gas limit in the near future. And like most people, I think that strong statelessness is unrealistic, like from a UX perspective. That said, like we kind of don't know yet where when state size becomes an issue. I think that's something that we're just starting to figure out how to test this year, but won't know very soon. What I'm most curious about is with state expiry, right? And we talked about this a little bit on the last one of these calls 2 weeks ago. If current state expiry designs are sort of not really feasible, right? And that they either don't reduce the state growth enough, I think, in the context of having a 10x or like a 100x even gas limit, or they require address space extension or contraction. Does having out of protocol state expiry solve any of that?
Yeah, so I'd say, to be honest, probably not. I'd say having it out of protocol doesn't fundamentally differ any of those things. Yeah, I find REST is kind of an interesting example. In principle, it's also partial statelessness with a state expiry rule, but their state expiry rule is not based on date or timestamp or whatever, but based on like some optimization problem of minimizing both the state that people need to store and the network bandwidth and other related problems. And so perhaps there's an avenue to go down there. Yeah.
Okay, thank you.
I want to say something else that Thomas shared some minutes ago in a Telegram group. And maybe also interesting to think about how private mempools versus public mempools relate to asking the users to provide a witness, if like witness creations might be fulfilled by private mempool owners. Of course, I mean, this is not like a free lunch solution, right? But it just might be a way for like improving UX in a way, if like most of the transactions will go through private mempools, and we can maybe not really ask users to solve this. But of course, if you want to have strong censorship resistance and you are using the public mempool, the problem still stands, of course.
Right, that makes sense. Thanks.
Okay, so if there's no more questions, we can continue with the agenda. The next item is a discussion on EIP 7612, which is the overlay tree EIP. To give a bit of context about this topic, when Karim was running the execution spec test for the tree conversion, he raised a question on why the code isn't migrated whenever a transaction touches the state of an unconverted account. So to explain a bit better, before the tree conversion logic activates, we have this period of time in which we have the overlay tree, and the idea there was that whenever a transaction touches an account, the write will happen in the Burkle tree. But in the current rules, converting the code at that point in time wasn't there, and I think Karim said that will simplify a bit the implementation on the client. So the idea is to discuss this a bit further. I don't know if Karim wants to add something else.
Yeah, why I was saying that is because in order to migrate the account, we need to have the code size and push this code size in the header. So as we are to read the code in order to update the header, why not directly also migrate the code? And also on my part, it will simplify when I detect if an account is present, to be sure that the code is already present in the Verkel tree, instead of doing two checking if the account is present, and if the account is present, also checking if the code is present. So it will reduce for me the amount of check, and I think it will also reduce the number of disk accesses if when we have an account in the Verkel tree, we know that we also have the code in the Verkel tree. So it's why I was asking Guillaume if we can also modify guess in order to have this kind of behavior.
Yeah, so there are two things here why we shouldn't do this, or at least why I'm against doing this. Okay, three things, because yes, we have to do it in Geth, and it's a bit complicated. Like, I have an issue explaining how I would do this, and I'm not sure it's very reliable. Like, I would have to work around it. Like, I would have to hack my way in. I'm not super okay. I have a bad feeling about this. That's, I guess, at the core, this is the real problem. Now, there are two problems that are a bit more. I'm looking for the word. Yeah. Okay, forget the words. I have two more problems. One of them is the witness size, because, for example, someone could bloat the witness by, I made some calculation. If it's a 30 million block, they could just write or access some account, and that ties, of course, into the next conversation, which is about converting accounts when they get touched and not at the end. But if you start doing this, if you start updating like the code or converting the code when you touch the account, you could find yourself in a situation where people, pretty much what Ignacio did with
not touch, only when we are updating
when you are updating
the account, not only touch. I'm not saying when we are just reading an account, when we are updating an account.
Right, yeah, no, when we are updating an account. Yeah, but updating an account could be just sending one way to the account. So you could send one way to every account that has 24 kilobyte code, which is pretty much the same attack as what Ignacio did when he took down some of the provers on ethproof.org, except I think even cheaper. And what you would do is just get 24 kilobyte codes, and this way you would bloat the. So I computed how much extra nodes that would represent in the witness, and that's about 3.7 3,700 leaves extra. So for example, if the stride is 10K, this is like one third.
But we not said that we will not have witnesses during the transition.
Did we say that? Because I'm trying to think, because I keep hearing contradictory opinions on this. We want them on for the purpose of syncing, like doing syncs. Yes, we want them for that.
But I think we decided that we don't need it for sync because it was too much of a hassle. The witness size will bloat. So I think we decided that we'll snap sync until the transition point, and then we'll do a full sync while we are in transition.
Oh, right. We do a full sync. Yeah, okay. I'm not sure who we is, because yes, I can imagine us Verkle oriented people or stateless oriented people to agree with this, but then there's what the guest team has been saying. That's why I'm a bit confused, and I'm not sure what the final decision is. I'm happy to go this route, but I think I think it's not a good idea in any case to bloat the witness. What we can do, however, to lower this risk is see how many leaves got touched during the but okay, actually we can't really do this because we can only do this if the tree sweep happens after the block execution. But if it happens before the block execution, which is item 5 on this roadmap, on this call agenda, we would have 10,000 leaves and then potentially 3,000 more, or maybe even more, depending on how many transactions there are that do this. No, sorry, the 3.7K is limited by the 36 million. So no, that would be about 4,000 leaves extra. Yeah. Okay.
Just regarding the transition, how you will represent a key that was in the Patricia market tree and not in Verkel in the access witnesses? You will say that the prior value was null or was present?
Yes. It's a proof of absence. Yeah.
Okay.
And then you have the new value, which is non-zero.
But the stateless client will not work as the node we have the value in the Patricia market tree, so it will be the execution of the event will not be the same.
So the execution client, the stateless clients would not be able to work. That's for sure.
Yeah.
However, like I said, we might want to use those proofs for the sync, because the sync would still need them if we decide to do a stateless sync this way. So yeah, you're saying, Karen?
No, because I'm just thinking if we really need access witnesses, if we say that we will do full sync during the transition, and it will simplify. I think it will simplify the logic like that.
Mm-hmm. No, I agree. I totally agree with this. It's just that I need to make sure the rest of the guest team is on board. Yeah, Ignacio?
Yeah, so to summarize a bit your point, and let me know if this makes sense. So you're raising a concern regarding the witness size bloat if we do the call conversion here. Okay, so that's one thing. And I think another thing is just execution load, because I know if there's no bound in the amount of writes in the Merkle tree that we might do if like a block migrates a lot of, like, even if we don't include witnesses during this phase, we rely on full sync, we have to still answer the question, if a block converts, thousands of 24 kilobyte accounts, you still have to do the writes to the new tree, right? And that might be a lot of work.
Yeah, so that was not my point, but that's absolutely a fair point. Yeah, that's an extra concern. You're right. Yeah. And on top of that, it's not just the writes; it's also the state root computation. Assuming we don't really benefit from the pooling of all those values together. Yeah. But yeah, as it is, I don't think it's a showstopper. We can always just say, okay, the network could handle 20,000 leaves, but because we expect potentially an extra 4,000 leaves to be created, instead of 20,000 leaves, we will do only 10,000 or 15,000, so that we have this buffer. So I don't think it's a showstopper. I'm just saying, yeah, this is what I don't like the idea. So there's a second point I was trying to make. It's that for me in the code, it's really hard to tell when code has to be rewritten, because in Geth, at least, the first time the code gets created, you have a flag. It's called dirty code, and it's set because the contract was just created, and we know that we need to update the code to disk. The second time, I have to say, I'm not really clear on how I could detect this thing. And this is why I already asked, but I'll ask you again because I'm really interested in this. How does you, Tanishq, and you, Karim, detect that this is the time to convert the code again, basically, to write the code? And how do you ensure that you don't write it multiple times? Like, you only write it when the code is created in MPT mode, and then when it's accessed, so that during the conversion, during the transition, so that you know that you have to write it again to the tree, and more importantly, that if the contract, if the contract is storage is written to multiple times, how do you ensure that you only write the code once, and not like, every time the contract gets accessed?
I think it will be difficult to explain, Lazak, but in Besu, we have a notion of accumulator. So when we are reading something, it's similar to the access witness. We have the prior value and the new value. And during the transition, I have an accumulator for the Merkle tree, and I have an accumulator for the Patricia Merkle tree. And when I'm reading something from the Patricia Merkle tree, so it will be marked as it was present in the Patricia Merkle tree and not in the Merkle tree, because it will be null in the accumulator of Merkle. So when I will compute the state root, I will detect that the prior version was null, so I will have to write it in the database. But in the next time, if I want to read it from the database, the prior value will not be null. So I will be able to detect that I don't have to write it again.
Yeah, and that's true. You have several account types, and I could have the same thing. Okay, and Tanishq, do you know how you're going to do this?
So right now, what I do is I calculate the state root twice. That's not like a good solution. I just wanted to make transition working. So what I do is, like, before we start executing the block, I move the data and I calculate the state root. Do not like process the data to the database or anything like that. Just calculate the state root, and then when you execute the block, you can very easily check if something was, like, while calculating the first state root, you can check if something was written already in the database, the workable tree, then you should not move it. And if it was empty, then you move the account or rewrite the account. And then when you execute the block, you use a different mode where you just like do the normal operation that you do during block execution. But I think I'll do something similar to what Karim is doing when I skip the two state root calculation thing. But yeah, I haven't thought about that yet.
Okay. Okay, thank you. Then I guess I'm reluctantly agreeing that this is what we should do, provided we keep some buffer precisely for the block size overload and the computation overload, overboard, going overboard. I just have to keep thinking, but I guess yeah, I agree we should convert the code. I just don't exactly know how to do it, so I might raise the point next time. But yeah, okay, I get the point, and I think it should be doable. It's just not going to be easy for me. Yep.
I think I got a bit confused, but I don't think so. I get why do we, like, for storage slots, I understand that we might need to rewrite again and again. But for account and code, if you're moving account and code at the same time, then I do not understand, like, why do we need to even check to avoid rewrite? Like, what I do right now is, if the data is not present in Workle, the new Workle tree, then I read it from the old data. And if it's already there, I don't I don't go to the PM partition Workle tree.
Yeah, I'm trying to avoid the database access every time. That is so I can't really check the tree. That's why I would like to not have to check the tree, because that's an extra read, and it's a fairly critical part of the code where you recompute the root. So you want to be going as fast as possible, because there used to be a bottleneck, and it could still be a bottleneck in the future. So that's why it's some information I would have to go fetch from the database, and I was hoping to not have to do that.
But anyways, when we compute the state root, you have to read what's already there, if I'm not mistaken.
Yeah, that's true, but it's in a different layer. So I would have, yeah, okay. So basically, you're right. It's not just the database read that is more or less necessary. It's mostly that I have to hack my way through interfaces. So yeah, okay. Okay, no, but I get the point. I'm not saying it's not possible. I'm just saying I don't like it. But if I find a good way to do it and prove that it works, then I'm happy to indulge.
But I think the reason of what Ignacio pointed out, that it will increase the execution load. I think that is a reason enough to not do it this way. Because, like, yeah, if someone wants to actually create an attack where it just like sends one into the accounts that have a lot of code, and that would slow down specific blocks. So I think that's a reason enough to not move code when the account is modified.
Yeah, but like I said, we can get some buffer so that we make sure it's not going to be a problem. I mean, it's inefficient because then our stride is 15K when it could be 20K, right? So we make what 25% less progress, but okay, we make the same progress eventually, but we don't go as fast. But I mean, if it's what it takes, yeah, I guess it's.
But this point is unrelated with the stride, right? This is something that happens before the conversion starts.
No, I'm not sure I get what you mean.
What I mean is, like, before the conversion starts, if we migrate the code when an account has a write, then there's nothing stopping someone to create a block that only writes to 24 kilobyte accounts and forces EL clients to do a lot of writes in the Berkeley tree. And all this is happening before the tree conversion.
Right. Yeah, that's also true, yeah. But I would say because we're converting nothing, then we definitely have the buffer, right? Because the limit, I mean, the computation is like 3,000 leaves, 3.7 thousand leaves. That should not be a problem. I don't think it would be. It's it's going to be extra work for the machines, but this is work they would have to do eventually. So might as well do it at a time. It's actually beneficial, I would say, because it's doing it at a time that is not where no other leaf is being converted, and once they're in the tree, they won't be converted again, which I would say is good because we don't have to. Yeah, like we're saving time in a way. We're starting the conversion early, even though, well, we might have to. We're in a situation where we might have to reorg. But ultimately, I would say that's not going to take the whole thing down.
But the problem, I mean, it's beneficial from the sense that you are front running a lot of work that would have happened in the tree conversion. But the point is, there's no clear bound of this work compared to the tree conversion, where we have the stride protecting us.
No, I think there is. I mean, from what I computed, which is like the maximum bloat you can give is doing this at least. It's 3,700 leaves. So it's well within the bounds that we currently have.
So it's basically 36 million over 2,100, something like that amount of 24 byte.
It's actually sending a transaction. Yeah, okay, that's the idea. Yes, it's just sending one way to contrast with 24 kilobytes. Yeah.
So that's way higher than the bound that we designed for the tree conversion, right?
Is it 30? Well, 20. Okay, either my math is wrong or it's not. No. Okay, I guess I have.
We can double check it. Yeah.
Yeah, let's double check the math, but from what I understand, it's fine.
Okay, so I mean, yeah, let's double check things offline, and we can come back to the topic in future SIG to see if we can reach some conclusion.
One small point about that: wouldn't it be possible to have a design where the amount of conversion that happens depends on the size of the execution witness? So let's say we're aiming for like 10K leaves per stride or per block, but couldn't we have it so that it's just the delta between the target and what's already provided by the EL block in execution witness? You see what I mean? Where, I mean, if we have like 3.5K that's already like converted in the by execution, we could just do like fill that up to 6.K, then we have a reliable number that we know clients will convert every block.
Yeah, so this is actually an idea that long ago Gotti suggested for the stride being dynamic instead of static. I think in the conclusion there was just that static is much simpler to implement, and it was mostly a complexity argument. But just to be clear, the discussion here is actually about a situation that happens before the tree conversion. So it's not really stride related. So the point here was that before the tree conversion happens, if we are migrating code, what is the worst case scenario there, and it might be too much low for real clients.
I mean,
but actually, if we, yeah.
Sorry, it's not just before, right? It's also during, because if you have a normal conversion, and on top of that, especially if the conversion happens before, like what we want to do on 0.5, we probably don't have the time to discuss that today. But if we do the conversion before executing the block, then you will have a fixed number, which is 10,000 leaves, and then on top of that, you might have another 4,000 or 3,700,000 leaves.
But during the conversion, this is a point already addressed in the IP, because you can only migrate up to, there's like a clear bound. Here's like a link on the IP touching on that.
Okay. For some reason, the link doesn't work for me. Okay, I guess we can maybe take that offline for now. And right, account tracking done in a single step. Conversion stride. Yeah, but that's not exactly what I mean.
If
Right, okay.
if you are touching the account, but it's not in the leaf we want to migrate by block or something like that, or
Come again?
now you are saying if we are touching an account during the transition, and not because we need to move an account by block.
Mm-hmm.
You are not talking about this part. You are talking about when we are touching an account during a transaction.
Yeah.
I think it's the same before and during the transition.
Yeah.
Same issue. Yeah.
Okay. I guess because we're almost at time and we have other things on the agenda, we can take it offline and we can let's sort it out. But I think it's manageable.
Okay. I think we have a bit of time for the next one, next item in the agenda, which is a discussion regarding this rule that we have for the tree conversion of not migrating empty accounts which have storage. Yes, Tanish?
I think we skipped the part where there's another the third also as a like sub part on storage root triggering the conversion, like changing storage
Oh, yeah.
slot.
Yeah, so there was, I'm sorry, yes. So there was another sub-discussion on the previous topic, which is something that we discussed in the previous call. In the previous call, I raised a point in which, yes, Karim was also mentioning whenever we write to a storage slot, a priori, the only data that might be written in the Merkle tree is that storage slot. But by the way that Geth works, that also the way that Geth works is that it would also migrate the account data because technically storage root changed. So Geth interpretation is that the account data changed. So that means that the account data should also be converted to the Merkle tree. So I think people wanted to touch again on this topic.
Yeah, I think now that people ran the test, passed the test, they understand a bit more what was meant here. I'm still against this idea because that's the way Guest does it. But maybe people want to make the case to do this. I think it's also connected to the previous issue of writing the storage, because then if you write a slot, you have to convert the account, and then the question comes whether or not you convert the code as well. But yeah, I mean, I guess it can be done in Geth, and once again, I'm not happy about it because it makes the code ugly. Yeah, the question is, how do you guys do it, and what's your preference?
I think I prefer like not moving the account when we are just writing to a storage slot. But I think right now the test assume that we move the account as well when we are writing to the storage slot.
Yeah, so right now, indeed, when you write to the storage slot, the account without the code will be translated. Yes.
Yeah, I prefer that we only translate the storage slot and not the account. But,
so yeah. Okay, that's what you want. And how do you detect that the account that the code has not been translated? That it's time to translate the code. How do you detect this?
I still need to work on that because right now I'm moving like code with the account. That's why I'm not passing those tests where we don't move the code with the account. So I need to rework that. I'm not sure how to do that, but yeah.
Okay. Yeah.
On my side, I'm not against this proposition to move the slot without the code, but it's not a problem if you are moving the slot with the count. It's not a big issue for me. Migrating the code with the count for me, it's a bigger issue. But regarding the slot, yeah, it's not really a big issue. So as you want.
Okay. Yeah, I'm looking at my code on how to do this. I thought I had the fix for this, but I don't really. I don't know if it's gonna. I don't know if it's going to work. Okay. Well, I guess Tanish would implement this and let me know how you do it, and I guess Karen too, and then we can. If everybody manages to do it, I guess that's the simpler way to do it. Yeah.
So for me,
Like,
it's working as it on my side for the slot.
For you, it's not what?
For me, I'm Bezu is working as get for the slot.
Yeah, for Nethermind, like the thing that I am proposing is already implemented. So maybe I can try to like implement something similar to get. It's not a huge problem, but yeah, I can give it a try.
Okay, then I will ask you for links so that I can go and check what you're doing. That would be informative.
Okay. So we have another 2 items in the agenda, but since we are running out of time, I think we can roll over them into the next call. So yeah, thanks everyone for joining.
Thanks everyone. Thanks Ignacio
Thanks.
for leading.
Yeah, take care.